This is Lecture-1, Chapter 4. You will learn in this first lecture, number 1, importance of carbon and its compounds, number 2, covalent bonding and physical properties of covalent compounds, and number 3, allotropes of carbon. First, I tell you about importance of carbon and its compounds. Carbon is an element that forms maximum number of compounds after hydrogen. Carbon and hydrogen combine to form such a huge number of compounds that no other two elements can do. Biochemistry is mainly the chemistry of carbon compounds. Most of the mass of living beings is of carbon, hydrogen and oxygen. Clothes, wood, plastic, food items, LPG, all these have carbon compounds. Amount of carbon in Earth's crust is about just 0.02%. It exists in the form of carbonates, hydrogen carbonates, coal, petroleum and natural gas. In atmosphere, carbon dioxide is about 0.03%. Carbon is the first or smallest atom that has exactly half of octet in its valence shell. It makes carbon a unique element that is most versatile. This also makes it impossible to completely transfer electrons to it to complete its octet or away from it, because in either case it shall acquire 4 positive or 4 negative charge. So how it can stabilize? For that it needs covalent bonding. Next I tell you what is covalent bonding. That is the subtopic number 2. To complete its octet, carbon atoms share electrons with other atoms because transfer of electrons would make it unstable in comparison to the sharing of electrons. Such a bonding in which electrons are shared by both combining atoms is called covalent bonding. Means in covalent bonding, complete transfer of electrons does not take place. Covalently bonded atoms form discrete molecules. A number of elements have covalent bonding. All multi-atomic discrete molecules have atoms covalently bonded. For example, H2, O2, Cl2, H2O and CO2. The intermolecular attractions are less in covalent compounds. Here you pay heed to the intermolecular attractions. We are not talking about interatomic attractions. We are talking about intermolecular attractions. So these attractions are very weak as compared to ionic compounds. Carbon compounds have covalent bonding, therefore low melting and boiling points. You know that the current is net flow of charges, therefore covalently bonded compounds are bad conductors of electricity because they cannot form ions, and the electrons are also not free to carry current. Let us see H2 molecule. Here 2 atoms of hydrogen, they share electrons with each other, and because in first cell the maximum number of electrons that can be accommodated is 2. In CO2, 1 carbon atom and 2 oxygen atoms mutually share 2 electrons of each other. Atomic number of carbon is 6, so the configuration would be 2 in K and 4 in L cell. And oxygen has 8 electrons, 2 in K and 6 in L cell. Now you can see that the octet of carbon as well as of both oxygen atoms is completed. Next I discuss about the allotropes of carbon. Some elements like carbon, phosphorus, sulfur, they exist in nature in different forms. These different forms are due to difference in the bonding in their atoms. Means it depends on that how their atoms are bonded with each other. In diamond, each carbon atom is bonded to 4 other carbon atoms. These atoms are situated in the corners of a regular tetrahedron. It forms a 3-dimensional rigid structure. Therefore, diamond is very hard and does not conduct electricity. Diamond is formed when high purity carbon is subjected to very high pressure and temperature. Another allotropic form of carbon is graphite. In graphite, every carbon atom is bonded to three other carbon atoms in the same plane so that a hexagonal structure is formed. These layers are placed on each other and these layers can slide because of one free electron from every carbon atom. That is why graphite has a slippery touch. It is very good conductor of heat as well as electricity because non-bonded electrons are free to carry charge or heat. Another allotropic form of carbon is fullerenes. These have fixed number of carbon atoms. The first one identified was of 60 atoms. It was named as Buckminster fullerene after the name of architect Buckminster Fuller, who designed geodesic dome structure. In the end, I summarize this lecture. In this lecture, you learnt that carbon is most versatile element that forms a very large number of compounds. It can form very big molecules also, the number of atoms in which can be in thousands or millions. All living beings have thousands of carbon compounds in them. Carbon and hydrogen combine to form compounds in such a number that no other two elements can do. In ionic compounds, atoms attain stability by taking and donating electrons. Carbon does not give or take electrons, instead it shares electrons to acquire stability. Sharing of electrons by two or more atoms to complete their octet is called covalent bonding. Intermolecular attractions are weaker in covalent compounds. Therefore, covalent compounds have lower melting and boiling points in comparison to ionic compounds. They are also not good conductors of heat and electricity. Carbon exists in different forms. One of the forms is diamond. In diamond, carbon atoms are bonded three-dimensionally. They form a rigid structure. Graphite is another form in which carbon atoms are bonded to three other carbon atoms in one plane, and one free electron from each carbon atom can move throughout the structure. Graphite is good conductor of heat and electricity because it has free electrons to conduct electricity or heat. It does not burn at routine temperature the charcoal burns or the coal burns. Charcoal is an amorphous form of carbon. Fullerenes, another form of carbon, have a fixed number of carbon atoms. The number of carbon atoms varies in the fullerenes, but that is a fixed number. Now, here is a question for you. What element after hydrogen and carbon can form maximum compounds? This is my first lecture of chapter 4. This chapter is to be continued in second chapter.